this video. This is chapter 1, lesson 6. So this is the last lesson in this chapter. This is explaining why surface water and the rain in Galetown. So if you watched my last video on a chapter review, I kind of touched on the surface water issue and the increase in surface water. So I want you to turn to page 30 in your workbook. And the question is, let me read you this letter from the data from the Galetown. We put together this data table for you. In it has data about the amount of rain from Galetown's recent rainstorms. It also includes information about the amount of surface water in Galetown. Remember, local surface water is all of the water that is at the surface and can evaporate, including water from the lake. So we have 3 storms here. One is before the lake and one is after the lake. 2 and 3 are after the lake, and as well, storm 4. So I'm looking at the local surface water level right here. High, high, high. And then it goes from mild, moderate, severe, very severe. So almost in an increasing order. I want you to, sorry guys, let me go. Use this to answer the questions on page 30 and think about the claims that are attached to it. So claim 1 is what we're really focusing on. At this time, you can pause. Okay, welcome back. So when we did our last video, we talked about, there was a portion that taught us about the relationship between water vapor and the amount of rain. And the more water vapor in the air, the higher the level of rain. So you should be thinking about how does the amount of surface water affect the amount of water vapor in the air? And what really is going on is that the more surface water, the higher amount of water vapor. This would mean that there's more water available for the sun to evaporate. And does the table give us evidence that the amount of rain increased after the lake was built? So if you look at this, storm 1 is the only one that is before the lake. Once we get from after the lake, we go from low surface water and the rest are high. So, which makes sense because if the lake is being there, there's a constant level of surface water. And as we go from the amount of rain, it goes from moderate to severe as we move on across the storms. So I want you to spend some time with word relationships. So after you're done with this, you're going to have to copy your sentences over into the Google Docs along with pictures of the pages you're completing in your workbook. So I want you to create sentences that explain why rainfall happens. And use the words below, which is air partial, which is a portion of air that's traveling together. Water vapor, which is water in the gas phase. Energy, the ability to make things change or move. Temperature, the measure of how hot or cold something is. And transfer, to move something from one place to another. Using these vocabulary words, I want you to come up with 3 sentences. At this time, you might want to press pause to come up with your sentences that would explain why there's more rainfall happening. When you're done with these sentences, you're welcome to come back and you'll write the sentences in your Google Docs at the end after you finish watching the video. All right, so welcome back. I'm not going to write any sentences here now, but I'm going to give you guys some more sentences in our next video, just so that you're not copying my answers. So we're going to move on. So what we're going to do now is we're going to model what goes on inside of two storms. So we're going to look at storm 1 and storm 2. And we're going to model in a diagram, on a water cycle diagram, what's going on here. So storm 1, we have low surface water and a mild amount of rain, 6 inches. And then storm 2, we have a high level of surface water and a moderate amount, which is 15 inches. You'll notice that the inches are in the parentheses, mostly because in science we always use metric system, but the conversions are right there. So 15 centimeters and then 38 centimeters. So we have a severe difference. It's more than double. So if you turn to page 32 in your workbook, I have here you'll notice I kept the rain, the data table here, the instructions of what I would like you to do, and then the storms. So this is storm 1. Storm 2 is going to look exactly the same, but I just want to model how this should look. So on yours, make sure you write in that this is storm 1. So on the first thing is that we want to look at the water, local surface water. And you'll see that there are 2 lines. The smaller one would mean a low amount, whereas the larger one would mean, make sure you guys can see where I'm at. The smaller one would mean low surface area, and the larger one would mean high. So in this case, storm 1 says that there is a low amount of surface water. Now, the amount of rain is also pretty low. So I'm going to circle, keep them both blue, right? When there's low surface water, there's also going to be low water vapor. And the temperature of the air partial is going to be high because it's evaporated. So right now we have a low amount of water vapor, but the temperature is high. And even outside, the air is also low, because as it goes into the atmosphere, it's going to be low. Now, we know that the transfer of energy is going to make the heat from the water vapor cool off, which is what causes the condensation. So the water becomes low and the temperature is low because it matches almost the outside temperature. So if the outside temperature was low in the beginning, it's going to be low on the outside, and also everything is going to come to one amount. And it's going to be a small rain cloud, right? Because we didn't have that much water. So low amount of water would mean low amount of surface water would mean low amount of rain cloud water, because there can't be more than what we started with. So when you're done with this, I would like you to press pause and try to do storm 2 on your own. And come back after you're done and we're going to talk about it. Okay, so welcome back. So storm 2 is slightly different in that there's a high amount of surface water. So instead of circling the inner circle, I'm going to circle the outer circle. So there's definitely more surface water. Now, this does not change the amount of surface water at the end, because the lake wouldn't really go down that much. There'll just be more available to transfer. Now, we never said anything about changing the outside temperature, so we're going to keep it again at a low outside temperature. And again, the temperature of the water vapor would be high because it's evaporating. And there would also be a high amount of water vapor because more water on the surface means more water vapor when it evaporates. So as we go to the next thing, the outside temperature was again low. So eventually what's going to happen is that water vapor temperature is that with that condensation is going to lower out to a lower temperature because the energy from the heat inside of the air partial will eventually leave and expand outwards. So it will come to an equal temperature, which we've seen in the diagrams. Also, there's still going to be a high amount of liquid water. So with the high amount of liquid water, that's because there was a high amount of water vapor. Water vapor comes from the evaporation of the surface water. So if there's high amount of water evaporation because there's high surface, the liquid inside of the clouds is also going to be a high amount. So you're going to want to go on the outside here. And because there's more water, it's going to be more severe rainstorms. So you're going to have more rain. So these two diagrams show us that as we go from low surface water, we have low amount of liquid rain. When we go to a higher amount of surface water, we have a higher amount of liquid rain. So you're not going to have any other work besides sending me the answers on the Word document. But tomorrow you're going to go over and write a CER for what caused the Gale Town to have more severe storms. You're welcome to use these two models to explain how surface water, the increase in surface water, can increase the amount of rain in a storm. Again, you're going to need evidence, which you are welcome to use this or the simulator data. And then you're going to need to explain it using the vocabulary words that are given to you on the CER. You should use all of the vocabulary words tomorrow. If not, try to use as many as you can. And you need to be able to pick a claim. If you're not 100% certain on a claim, you can definitely support one claim without saying that the others are wrong. So your CER should answer the question, what caused Gale Town to have more severe rainstorms? And right now, we mostly have evidence for claim 1, but we do not have evidence to say claim 2 and 3 are not correct. So I look forward to reading your reflections, and I'll see you in my next video. Chat.